Today's lesson is on solving addition and subtraction inequalities. Solving inequalities are similar to solving equations, except there's an inequality sign in the problem instead of an equal sign. We will also need to provide a graph of the solutions. So in this first problem, you can see we're finding the solution of b subtract 4 is greater than -2. So just like when we solve equations, you can draw a line straight down from the inequality sign, separating the left side from the right side. So we're going to undo. Instead of b subtract 4, we want to do the inverse and add 4 to both sides. And then draw your line straight across. -4 plus 4 is 0, so we can show that they cancel by putting a backslash through it. Bringing down what's left, we have b. Now here you want to bring down your inequality sign. -2 plus 4 is +2. So this is our solution, stating that our answer b is greater than the number 2. So with inequalities, because there's a range of answers, you need to provide a graph that will graph all of the solutions. So to graph b is greater than 2, we're going to place an open circle at 2 and shade to the right. So as a reminder right here, when you're graphing, you will use open circles anytime you have a less than or greater than symbol, and you will use a closed circle when you have less than or equal to and greater than or equal to. So you can see at 2, I have an open circle and I'm bolding to the right. Basically what this graph tells the reader is that at 2, the answer begins everything right of 2. Because the circle is open, it doesn't include the number 2. So if we went back to check our answers, if I placed a 2 in here, 2 minus 4 is -2. -2 is definitely not greater than -2, so you can see why there's an open circle here. It does not include 2 as an answer. However, because it's bolded here, everything to the right of 2 is an answer to the inequality. So if I maybe select 3 and place it in for b, 3 subtract 4 is -1. -1 is definitely greater than -2. Okay, let's go on then and do some sample problems. Just as a reminder, you will use an open circle when it's less than or greater than, and you will use a closed circle if it's less than or equal to or greater than or equal to. And that is just for your graphs. Okay, so in this first example, we are subtracting 14 from m. So let's do the opposite. Let's add 14 to both sides. -14 plus 14 is 0. So we're going to bring our m straight down along with our greater than or equal to symbol. -10 plus 14 is equal to 4. So this is only part of our answer. With inequalities, you have to provide a graph. So if a graph is not drawn for you, just go ahead and draw a single line. Always show where 0 is, and then show where your answer is, which is +4. I'm going to put it right here. Since it's greater than or equal to, we need to make sure we use a closed circle because 4 is part of our answer. Since m is greater than or equal to 4, we want to bold to the right and show that all of our answers are to the right of 4. Now because we're drawing this instead of us using like the computer to make a bold, I like to usually show my arrow moving this way so that all of my answers are to the right of 4. So in other words, m, our answer, could be anywhere along this line, and because we have an arrow, it moves to the right of 4 into infinity. Let's do the second one. I can already tell that I'll be using an open circle in my graph because of this sign. Let's add 2 to both sides. So here's that line if you care to draw it. This is 0. Bring down t is less than 4 plus 2 is 6. So I'm going to circle that. I'm also going to provide the graph that goes along with it. Always show where 0 is located. And then this is going to be +6 somewhere down here. Since t, our answer, is less than 6, I'm going to draw an open circle at 6, and then all of the answers would be to the left of 6 this time. So in other words, t could lie somewhere along this line and move into infinity towards the left of 6. However, because we have an open circle here, the answer does not include 6. Let's try a few more. Y subtract 3. Let's do the complete opposite and add 3 to both sides. These cancel, and y is less than or equal to 7. When you draw your graph, it can be just as simple as this. Always show where 0 is. Positive 7 is somewhere down here. We are using a closed circle, and it says y is less than or equal to 7. Where are numbers less than or equal to 7? That would be to the left. In the next example, we will be adding 9 to both sides. These cancel. D is greater than or equal to. This is a negative 12 plus 9, so that would be a negative 3. Again, use your number line here, show where 0 is. Now we want to show where negative 3 is. That would be to the left of 0. Since we have greater than or equal to, it is a closed circle. D is greater than or equal to negative 3. Numbers greater than or equal to negative 3 would be to the right of negative 3. Moving on then to numbers 5 and 6, we are going to add 17 to both sides in number 5. Negative 17 plus 17 is 0. Let's bring down our W is greater than. If we add 13 and 17, that's going to give us 30. So our answer is W is greater than 30. So again, making a graph, showing where 0 is. 30 would be somewhere to the right. We have an open circle. W is greater than 30. It is going to move to the right. In example 6, we will be adding 22 to both sides. These two cancel, and A is less than. We have a negative 7 plus 22. So we have to find the difference between the two, and that would be 15. So A is less than 15. Showing the graph, definitely show where 0 is, and positive 15. We need to use an open circle. A, the answer, is less than 15. Numbers that are less than 15 are to the left of 15. Okay, in our last two examples here, we have a writing problem. Explain how you would solve t subtract 15 is less than or equal to 5. So this is a written statement. So you need to tell me what you would do to solve number 7. I would say you need to first add 15 to both sides, and then you would get t is less than or equal to 5 plus 15 would be 20. Then you would graph the solution and tell me how to do that. In our last example, Anita is baking dinner rolls and pumpkin bread. She needs 4 cups of flour for the rolls, and she needs at least 7 cups of flour left for the pumpkin bread. We have to write and solve an inequality to determine how much flour Anita needs before she starts baking. All right, I obviously need a variable, so if I use C for cups, I need at least 4 cups for the roll. So let's say I start with C, that's how many cups of flour I start with. I take away 4 because I'm baking the rolls. And when it says I need at least 7 cups of flour left for the pumpkin bread, I want the left side to be greater than or equal to 7 to ensure I have enough flour for the pumpkin bread. So once I'm here, I can go ahead and solve and graph that, and then I would come up with my answer. So let's add 4 to both sides and see what happens. I get C is greater than or equal to 11. So it looks like I need, or Anita needs, 7 or 11 cups to actually do both of these particular items for dinner. If I go ahead and graph that, I definitely want to show where 0 is, and I want to show where 11 is located. This would be a closed circle, and it would bold to the right. We're all done talking about addition and subtraction inequalities.